Example 1.2. The electrostatic force on a small sphere of a charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Then there are two questions. A. What is the distance between the two spheres? And B. What is the force on the second sphere due to the first? Here in the diagram, there are two spheres having charges 0.4 microcoulomb and minus 0.8 microcoulomb. This is the case of unlike charge. Hence, the force between these two charges is a force of attraction, and that is given here 0.2 Newton. What we have to find is the distance between the two spheres. Hence, we will consider it as a x. And according to the Coulomb's law, we will find the distance between two spheres first. So let's start it. So we have initially Q1 is equal to 0.4 microcoulomb, which is 4 into 10 raised to minus 1 microcoulomb, which is 4 into 10 raised to minus 1 into 10 raised to minus 6 coulomb. So finally, we have 4 into 10 raised to minus 7 coulomb. So I am converting this value into SI unit of charge, that is a coulomb. The next, so I am converting the value of charge into SI unit, that is in coulomb. Similarly, Q2 can be written as minus 0.8 microcoulomb, and that can be written as minus 8 into 10 raised to minus 7 coulomb. So these are the two charges which are given in the problem. The force of attraction between the two charges is 0.2 Newton. So according to the electrostatic force of attraction, according to electrostatic force of attraction, we have F is equal to K Q1 Q2 upon R square. Here the value of K, which is 9 into 10 raised to 9 Newton meter square coulomb raised to minus 2, and that is the value of 1 upon 4 pi epsilon naught epsilon r, as epsilon r is 1 here for air. Okay, for air. So we simply take 1 upon 4 pi epsilon naught as a K value. As we already discussed the same case because of the air as a medium in the example 1.1. So we are interested in finding value of r, so we will modify the given equation this way and substitute the value. You will get 9 into 10 raised to 9 Newton meter square c raised to minus 2 into q1. Now q1 is 4 into 10 raised to minus 7 coulomb. Q2 is 8 into 10 raised to minus 7. Here I am purposely not taking the value of Q2 in negative, because by substituting the value of Q2 here in a negative form, and if we know the distance between the two spheres, we will find the force and which comes out to be negative because of the Q2 is negative and indicates the force is attractive nature because of the unlike charges. Here we are interested in finding the distance, hence we are simply taking the magnitudes by removing the negative sign on Q2. So we have a F value that is given 0.2 Newton. So let's take a look on units cancellation. See this. Here we have a units Newton meter square C raised to minus 2 again C again C. So C raised to minus 2 and C square will get cancelled here and upon Newton is there. So Newton get cancelled. We are left with meter square. What we have is R square that comes in meter square. We are interested in R, but before that let's simplify the given step by using the following steps. 9 into 4 into 8 upon 2 into 10 raised to 9 minus 7 minus 7 upon 10 raised to minus 1. Then 2 ones are 2, 2 twos are 4. 9 twos are 18 into 8. 18 into 8 into 10 raised to 9 minus 7 is 2. 2 minus 7 is minus 5 and minus 5 plus 1 as this minus 1 comes out to be plus 1 here, and finally what we have is 18 into 8 is 144 into 10 raised to minus 4 meter square, that is r square. So finally we have r square is equal to 144 into 10 raised to minus 4 meter square, and then r is equal to under root of 144 into 10 raised to minus 4, and that will be meter. As 144 is square of 12, so 12 will be comes out, and under root of 10 raised to minus 4 is 10 raised to minus 2 meter. It means 12 centimeter is the distance between the two spheres. And finally, we will write the result that the distance between two spheres is 0.12 meter, that is 12 centimeter. So in the second step, we have to find the force on the second sphere due to the first. So they have given the force on the first sphere due to the second. So this sphere will experience the 0.2 Newton force due to this sphere. The same force will be experienced by this sphere because of this sphere. So the answer is 0.2 Newton is the force experienced by the second sphere due to the first. Okay, so we will write this in a statement form. So as the both spheres attract each other, as both spheres attracts each other, with the same force, therefore the force on the second sphere due to first is also 0.2 Newton. Thank you.